My school. We are on.
Jamie?
Tutorial is sequences series.
Oh, you still have sequence and series. What was statistics?
That's the next chapter.
Oh, they haven't touched on discrete and variable at all.
Wait, no. Yeah, they haven't. The next chapter is probability, I think.
Oh, okay, very good. Means we are ahead.
I'm on discrete random variable.
You're on discrete random variable.
Yeah, I'm going to the next one is binomial distribution.
Okay. So the last time I touched the binomial with Jamie was like a while back also. So today, right, my objective is to re-go through DRV binomial again. Okay? Okay. For the... Never mind, I'll just use my notes here first. Okay, I will go through the content first, very, very briefly. Then we use questions to understand how we can be tested during the exam. Okay. So for DRV, right, most importantly is, okay, you need to understand for DRV, which means discrete random variable. Okay. Because it comes from random variable. We have discrete random variable and we also have continuous random variable. Okay, what is discrete random variable? Discrete random variables are basically what? Random variables that are what? Anybody know?
No.
Jimmy, they are measured in terms of what?
Whole number.
Yes, very good. They are integers. Okay, so all these random variables, they are basically measured in integers only, like number of goals scored, number of phones you have. You cannot have half a phone, right? Make sense? Yeah. So it's all measured in integers. For continuous random variable, it's all measured in real values. So it can be like, amount of water drank, you know, like the length of your hair, the height of people in your class, the weight of the people in your school. Those are continuous random variables. Okay? So in discrete random variables, you are only measuring integers only. So for discrete random variables, after that we will move on to this thing called binomial distribution. Because in binomial distribution, we are only measuring discrete random variables. For continuous random variable, it will be in normal distribution. Okay. Understand?
Yeah.
Can, huh? Great. So now I will touch on discrete random variables first, and continuous random variable, it will only come in when we go to normal distribution. Okay. So there is this one thing that I'll only go through the important points in discrete random variables over here. There's this one thing that you learn in discrete random variable is this table. Okay. This table. So you have this table, something like that. Okay. So you have x. You have x and you have probability of x equals to x. Right? So you have 0, 1, 2, 3. We have A, B, C, D. Probability of each corresponding x value. What is this called, Renee?
What's what called?
What is this table called?
It's called something.
It's called something nice. Jamie, what is it called?
Probability distribution function.
Correct. Okay. is called the probability distribution function. Correct. Which is also known as the PDF. Okay, from now on, I will keep repeating PDF. What I mean is probability distribution function. Why? Because it's a function that distributes the probability. Okay, it's a function that distributes the probability. It tells you that, okay, when x is equal to 0, it is this probability. When x is equal to 1, it's equal to this probability.
Yeah.
Understand? I mean, now
Yeah.
it is hard to see because, okay, very important is, by right, we should be defining what is x. So let's say x is the number of goals Sean scored. Shit. In a soccer match. Okay. So when the probability of him scoring 0 goals in a soccer match is A. Probability of him scoring one goal in a soccer match is B, so on and so forth. Okay. So the next important thing to know is that the sum of these probabilities, okay, the summation of all the probabilities is always equals to what?
1.
1. Very good. Okay. Which means, right, x equals to 0, 1, 2, and 3, right? They are exhaustive of all the possible number of goals that Sean can score. Which means, right, Sean cannot score 4 goals. Sean cannot score 5 goals. Or rather, he hasn't scored 4 to 5 goals yet. That's why there is no probability to it. So whenever you see a table, right, all the x values are exhaustive. Means those are the only possible x values. Get it? Okay, if I'm moving too fast, slow me down. Okay, so when I mean summation of all probability equals to 1, it also means that for A plus B plus C plus D will be equals to 1. This is an important property where they will always try to test you. Okay. So the next thing to know is the expectation. Do you know what's expectation?
Kind of.
Kind of. Okay. What is expectation? When people ask you, okay, what's the expectation of you
The mean.
It's the mean. Okay. Yes, it is the mean. It is the mean. It is also the average. Okay. But we are no longer going to find mean and average like how we do so in secondary school. You know? Like last time we will say, okay, let's say John has like $5. Mary have like $4. Then say Sean have like $3. What's the average amount of money that they bring to school? Then you'll be like, oh, 5 plus 4 plus 3 divided by 3, right? Yeah. But this is no longer true anymore at your level. Because for every amount that John brings to school, there's a probability tied to it. He can bring $5 today, but it may not be true anymore. Okay? Like tomorrow he may be bringing $4. The day after he may bring $3. We don't know. So we can no longer use this way of calculation for mean, or rather average, or rather expectation. Okay? So hold on now, let me explain further. What? Okay, because now every number comes with a probability. Okay, last time when we divide by 3, it's because we are using 5 times 1/3 plus 4 times 1/3 plus 3 times 1/3. Okay, the reason why we did this was because we assumed that for every number, they have equal probability of happening. Means there's a 1/3 chance of John bringing $5, 1/3 chance of Mary bringing $4, 1/3 chance of Sean bringing $3. This is why we divided by 3, because from here we can see it's actually equals to 5 plus 4 plus 3 over 3. We are actually using the amount of money, okay, which is the random variable, multiplied by its corresponding probability to find the mean or expectation. But right now, at JC level, when we find an expectation, we have, in this case, we have to use 0 times A plus 1 times B plus 2 times C plus 3 times D, which is also equivalent to the summation of X times its corresponding probability. Everybody understand?
Yeah.
You need to understand this one. Your teacher went through it.
Yeah.
Okay. So what happens when, okay, now what happens when they give you this? What happens when they give you this? How are you going to find the expectation of X squared given that it is relevant to this table?
Just square the
Sorry? I hear something. Just square the X. Like how?
But one remains the same.
Can someone just write something on the screen so that I just write answer on the screen?
Okay, wait.
Anybody?
Okay.
Okay. Vinny, do you agree?
Or is it the other way around?
I don't know. I'm asking you guys.
Yeah, then plus.
Is that it?
Yes. Correct. So both are correct. Okay. So this is correct and this is also correct. So we will only be squaring the X value. Okay. This is something that some students will do. They thought that, oh, expectation of X squared, so you square everything. No. What you are squaring is you're only squaring the random variable. You do not square the probability. The probability remains constant. Okay, no matter what it is. Even if I'm finding expectation of X cubed, okay, it will become summation of X cubed times the same probability again. We do not cube the probability or square the probability. It doesn't make sense. It should not affect the probability. Can?
Yeah.
Okay, very good. Okay, so if you need to learn about expectation, we should also learn about this thing called variance. Okay, so the formula for variance, do you have, okay, this one, of course, you have to memorize. All these formulas you have to memorize. You have to know how to, you may not need to memorize it, but you must know how to find it. The formula for variance, okay, what I taught Jamie was, or rather, did your school teach you how to find the variance, Vinay?
Yeah.
How?
Do I write?
Yeah, just write it down.
Oh my god. Okay.
You're using what? Apple Pen? Ah?
No, I'm using my finger. The pen sold out.
Oh, you're using your finger. Ah?
Yeah.
No, you have like any stylus at home? Ah?
No.
Okay. Actually, stylus quite cheap.
No, like as in like it's sold out. I'm gonna buy it soon.
Oh, you're gonna buy Apple Pen?
Yeah, soon. Cause I just bought the iPad only, what? Then it's sold out.
Oh.
Ah, damn it. Okay. Is it this?
Correct. Okay. So I mean, it's quite taxing to memorize everything, lah. So how to not memorize this? Okay. So what I told them was, you always say in and out or out and in. Which one will you say?
Ah, and then.
Huh? You say out and in? You don't say in and out. Why will you say out and in, man? You're the first person who tells me that you say out and in.
Okay, in and out.
No, but seriously, you say out and in. You just
I mean, I don't even say that. I don't even say any of that.
Oh, okay. Like you say like, hey, that is true lah. We hardly use this phrase lah. But usually, if you want to say it, you will say in and out, right?
I guess.
You guess. Okay, never mind. We just take it as in and out lah. Because
Okay.
I comes before O. Okay. So in case during exam you stun, right? Then you don't know whether, shit, is the square inside first or the square outside first? Okay, just remember it's always in and out. The I comes before O. Okay, so you always square the inside first, then you square on the outside. Okay?
Yeah.
Yeah. So we have already gone through on how to find this expectation of x squared. Okay. For this expectation of x is simple to find. We already found it earlier over here. So you can just square it. Okay? Okay. So these are I'm just going through techniques. This is a bit dry, I understand. After we go to questions. Okay, lastly, I'm just going to touch on one last thing, which is the properties of expectation and variance. Okay, properties of expectation and variance. Let's say I have expectation of 2x minus 3. Okay, when we have this, what do you suggest? How are we going to find expectation? Considering that we know that, okay, expectation of x is 5. How are we going to find expectation of 2x minus 3? Anyone?
Die, right?
Sure.
Huh?
Sure. At anytime you guys want to write anything, you can just write. Anytime. Okay, thank you. I know what you're going to write. Oh, okay. Who wrote? Jamie wrote this, right? Okay, is there an alternative answer?
That's very lame.
Yeah. Okay, Kenny.
Okay, so this is the correct answer. Okay, why? Because it works just like algebra. When you have expectation of 2x minus 3, what happens is that you can split it up into expectation of 2x minus expectation of 3. From your expectation of 2x, you can factorize out the 2 to give you 2 expectation of x. Expectation of 3, okay, 3, it's not a random variable, it is a constant. So there's nothing to expect out of it. You can only expect, what's your expectation of 3? Like, if someone comes out to you, what's your expectation of 3? It's just 3, right?
3.
Yeah, there's nothing to expect out of it. Yeah. Understand? Okay, this expectation is simple. But for variance, okay, there will be a little bit of difference to it. Now I have a lot to erase.
You cannot like box the whole thing anyway.
Actually, I think can. Wow, you damn smart eh. Can. Power. Didn't know about this. Power. Okay, next. Variance. Okay. Variance 3x minus 2y. Open to the floor. You all know I just finished my reservist, right?
No.
Oh, you don't know.
Why?
I just finished my reservist this week.
Okay.
Yeah. So right. No, I wanted to share a story. I have like when I was in the jungle, right, for the past 5 days, right? Like on the second night, we were like in the middle of the jungle. Then after that, right, 2 of my friends, right, they were like,
started coughing.
no lah, siao, that one will be too scary. two of my friends, right, they were like, hey Kenny, you want to just go and eat some hor fun? I was like, how to eat hor fun? He was like, we walk out ah. Like they wanted to walk. We were in the middle of nowhere. I don't even know where I am. Like right smack in the middle of a forest. They wanted to walk out of the forest to go into like the HDB area. So they walk. They really went out of the forest and then they came back.
Your whatever captain never say anything there.
Exactly. So because I'm their sergeant, they were my men. Then after that, my officer came and asked me.
Wait,
Yeah,
why you the leader?
What? Sorry?
Why are you the leader?
No lah, I was just in charge of them ah.
Oh.
Then after that, my officer
So
came and
like
asked
a
me.
group leader?
Yeah, something like that. Then they were like, hey, where are the 2 of them? Then I said, they went to Bangsai. They went deep into the forest to go and Bangsai. Wow, they really went out to like eat for like 2-3 hours, then after that walk back This is what happens when you have Google Maps.
Oh.
Yeah. If not, it's not possible to get back. Okay, coming back to this. Who wrote this?
Me.
Jamie, do you think it's correct?
Yeah.
I think this is too easy lah. Okay, so now we
Because
are
my
done.
school notes is next to me.
What?
My school notes is next to me. I'm just copying.
Yeah, it's good. Because at the start, you need to do this kind of reference when you do your tutorials or like when you do your lessons. It's good to have this kind of reference because it makes your brain register, so it becomes a muscle memory. So you guys need a break before I move on to tutorial questions.
No, I don't need.
Jimmy, you need or not? Okay. So have you attempted your tutorial questions already?
No.
Not yet.
Tutorial is complex.
But your discrete means your school haven't asked you all to do the DRV tutorial questions.
No, we are for tutorials we are doing complex.
Steady. Okay. So so to make things simpler, right? Can you take a snapshot of the first page of the tutorial and send me on WhatsApp now? I'll try to take it upright. Jamie, online tuition better, right? So you can use your phone. I can see it.
I'm not.
You sure or not? My gut feeling tells me that you are. But it's okay lah. You're very powerful now.
I have like 3 tutorials.
You had 3 tutorials for discrete random variables.
No. Or like the whole topic.
Okay, can. So what we're going to do is we're going to use Renee's tutorial so that you know don't have to go through like extra questions. It's pointless to do that. Tutorial
The
questions
first page
are
is the self-practice.
okay, cool. So I think easy, which means they are easier questions, right?
Yeah.
Yep. Oh, it's not very clear. Okay. You're going to have this thing at the bottom right of the page. Okay. Every single step that you take, right, every single question that you read, always have to redirect back to understand what is the setter's intention. Okay. Once you establish a communication bridge with the fellow on the other side of the paper, that's when you know what to answer the person. That's when you know what to give the person. Okay. But to even identify the setter's intention, you need to break down the question first. Okay. So now we have to look at this question. Okay, the random variable X has probability distribution, this thing. Okay, they give you probability X equals to whatever. Okay, so firstly, the topic here has to be discrete random variable. Yeah, the topic here has got to be discrete random variable, right? Then when we look at this equation here, okay, when we look at this equation here, this is called the what? Winning.
I don't know.
This equation is called what, Jamie? You guys just told me just now, what?
What? The oh.
What's it called?
I don't know.
It's made out of 3 letters.
PDF. Oh, the table.
Yes, yes. It's called the PDF. It's a probability distribution function. Okay, probability distribution function need not only come in table form. Okay, it can come in the form of an equation as well. This is something you need to know. Why? Because this equation can be translated back into table form as well. Okay, because now let's say if I were to draw a table. Okay, so this is X, and this is probability of X equals to X. Okay, so this will start from 0, 1, 2, 3, 4, 5. Okay, this will be an infinite table because as we can see here, right? There's no end to it. They put 3 dots and there is no there's no closure. Right? So from here, if you were to sub in X equals 0, we will get C. When you sub in X equals 1, we will get 4 over 5 C. When you sub in 2, we will get 4 over 5 square C. So on and so forth. So what I'm trying to say here, right, is that the equation can be translated into table form, which is still a probability distribution function. Understand?
Yeah.
Okay.
Yeah.
So back to the setter's intention. When we look at this question, what do you think the setter wants to test us on? Given that what we have went through just now. What's the intention of the setter here? What does he want?
Make us lose marks.
Exactly, correct. Yes, he wants to make us lose marks. Very good. So in an exam, right, it's not about scoring marks. It's about protecting your marks. You are right. You're not wrong. But to even protect your marks, you need to give the person what the person wants. So what is the when this setter, right, created this question, what does he or she wants to test you guys? They say find the value of the constant C. How to find? Anyone? We only learn a few things about a PDF only.
The sum equals to 1.
Yes. So now you see, once you understand that, we learn that in a PDF, the summation of the probabilities equals to 1. So that's the intention of the setter. He wants to test whether if you guys understood that, the summation of the all probabilities is equals to 1. So when I sum this whole chunk up all the way to the end, it will be equals to 1. Okay? Yo. Okay. I give you all 2 minutes to do up this question. 2 minutes to do up this question. By 1:55, I'll be going through.
I'm full scared.
Yeah.
Like at home.
At home. Yeah, at home. Correct. Unless you're at somewhere else. Anyway, this is your tutorial. You got to do it anyways. For Jimmy, just take it as revision.
will you sum the whole thing up to 1 if like the x goes to infinity?
Sorry again?
How you sum the whole thing up into 1 if the x goes to infinity?
You are asking the right question. Very good. You are asking a question that you can answer. But it is a very, very important question. I was waiting for you guys to ask me that. What do you think? The hint is here. Take a look.
Oh, okay.
Take a look.
GP.
Who said that?
Renee.
Power.
So what? Then
Power.
what?
So what do you
They
think?
link 2 topics.
What?
They link 2 topics.
Yeah. They did.
On the
but
first question.
What? No, okay. They are not flouting the rules, okay? They can link topics one. It's just that at A levels they try not to because it will get a bit confusing. But
So
in
why would you do
DRV,
that? This is the first question.
exactly. But in DRV, right? No, this is a question setup. When I send you guys the concept map, right? I'll be edit. You will see that this thing is on the concept map. They always like to do this. It's a question setup. They always like to add in a GP into DRV, into PDF. And they always like to use ... to make you use the sum to what?
Infinity.
Yes. And what's the formula for sum to infinity, Renee? Do you remember?
No.
Hey, I told you must memorize. Must memorize.
The convert. Oh. A over 1 minus R.
Yes. Correct. The best way to memorize is to rewrite it again and again and again.
So 1 equals to C over 1 minus 4 over 5.
Sorry again?
So C equals to 1 over 5.
Okay, I haven't worked it out yet. I was waiting for you guys so that we can go through together. Okay. So, are you done yet? If you're done, I can go through it. Okay. So over here, right, we know that sum to infinity is equals to A over 1 minus R. A being the first term. Sum to infinity, we already know that the summation of all the probabilities sum up together gives us 1. So A is your C, and then R is your 4 over 5. So over here, you will have C over 1 over 5. So C is equals to 1 over 5, which is correct. Just now, what you said was correct. Understand?
Yeah.
So understanding the setter's intention. Firstly, they gave us this. So when the person was creating this question, it's like, okay, I'm going to give the PDF in the form of a GP. You know? So I purposely put 4 over 5 to the power of X so that this will simulate the formula of a GP. So because the common ratio will be 4 over 5. Then I'm going to extend this X all the way to infinity to see if they can identify that this is sum to infinity. Get it? Yeah. Once you understand how this person create a question, it will get a bit easier. Okay, ma? Okay. Anytime you all need a break, can just let me know. Or you want to take 5 now? Power. Okay, question 2. So same thing, break down the question first. But obviously this is not going to be a A-level kind of question. Okay, this is just a tutorial level kind of question. Okay, 2 marbles are drawn without replacement. Okay, this is when I will underline. Everything that I'm annotating here is exactly like what I will do if I were to be in an examination hall together with you guys. Okay, so if we are going to do the same thing, we are going to get the same marks. Very simple. Okay, always annotate. If your paper is too clean, you are done. Because your hand is not talking to your brain. Your eyes not talking to your brain. Then that's it. Your brain is doing all the work. It's very tiring. And you have to do this for 3 hours. It's crazy. Okay. So 2 marbles are drawn without replacement. Without replacement means that it's going to the probability will be affected, you know, because it's dependent. Okay, one event will depend on another event, which means the probability will be affected. From a box containing 3 orange marbles, 4 purple marbles. Okay, I have 3 orange, 4 purple. You need okay or not?
Yeah,
I heard you cough.
because I choked on my coffee.
You sure or not?
Yeah,
Not COVID, right?
no.
Okay. If X is the random variable representing the number of purple marbles drawn. Okay. X is the, so now we have to write down. Okay. Define, always define random variable. If the question gives you the random variable. So X is equals to number of purple marbles drawn. Okay. If the question gives you the random variable, you have to name it. You cannot just leave it as it is. You get what I'm trying to say? Because on the question paper, right, the marker, right, will not look at the question. The marker only look at your solution. So even if the question, inside the question, they define what is X, right? The marker will not know. They only look at your solution. Okay? So from here, we need to find what is the expectation of X in part A. How do we find this? Oh, sorry. My bad. Find the probability distribution of X first. So find me the probability distribution of X. When they mean probability distribution of X, they basically mean the PDF. Okay, they want you to show the table. They want you to show the table. So we know that X is the number of purple marbles drawn, and then they say 2 marbles are drawn.
So it's only 1 and 2.
2 marbles are drawn. So what is the different? Remember I said we got to exhaust all possible number of purple marbles drawn, right? So when there are
1
2
and
marbles
2.
drawn, so Rini, your answer is 1 and 2.
I don't know.
Any other answers? Maybe we can ask Jamie.
What about 0?
What do you say?
Oh yeah.
0.
Solid lah. You see, even when she's using her phone, right?
Hey, oh my god, shit.
Even when she's using her phone, right? I know one. I know you, man, Jamie.
You know nothing.
I know you. If anything, right, I know you better than I know myself.
Uh-huh.
We have 0, 1, and 2. Okay, so this is my X, and this is my probability of X equals to X. Okay, so we have to find what's the probability of having 0, what's the probability of having 1, and what's the probability of having 2 purple. Okay, so what people will do is, okay, how am I going to find 0 marbles? 0 purple marbles. Hello, anybody there? How am I going to find 0 purple marbles? When I have 0 purple marbles, means both marbles are what?
Orange.
Orange lah, right? Very simple. And remember,
So
it's
3/7 times 2/7.
3/7 times.
2/7.
Then this one is when the marker will take marks from you. This is when the markers will
Times
take marks from
something
you.
else.
Remember, I mentioned this. Can you see what I'm highlighting?
Yeah.
Without replacement.
Times 2. Oh, 3/7 times 2/6.
Very smart. Okay, don't set yourself up for the person who take marks away from you. So that's why I say always annotate, highlight the question, underline the question, filter out the important points. Okay, what about 1 purple? What about 1 purple? Okay, wait. Or rather, what about 2 purple? Tell me two purple first. 2 purple is easier, I think. Jamie,
Yeah.
how to find X? What's the probability for X equals to 2?
Or 2 purple marbles.
Yeah, I want 2 purple marbles. Correct. How?
4/7 times 3/6.
Yeah, correct. Meaning, do you get this?
Yeah.
Correct, right? How do you find 1?
3/7 times 4/6 plus 4/7 times 3/6.
That the person who did this, right? The person, if anybody were to follow your method to find probability of getting 1 marble, right, is a very, very, very hardworking student.
Because you write everything.
Correct. But we are not here to be hardworking. We are here to be smart working. You know, we want to get the
Yeah.
most marks within the shortest period of time. So that's the reason why I want to do 0 and 2. I don't want to do 1. Because I know 1, right, I have to calculate more stuff.
So 1 minus 1 over 7 minus 2 over 7.
So correct. 1, the whole probability here equals to 1, right? So we just minus this and minus this, then we will get this. Understand? So in exam, do not find every single probability outcome. Just find the total number minus 1. Then that last one, right, you use complementary set to find. 知唔知道? This will be a smarter move. Okay, so once you get the table out, right, okay, because you have to understand how are people being eliminated during an exam. There are some people who don't even understand what is a probability distribution. They don't know what to find. They skip the question. Some people, they know how to find probability. They know the probability distribution, but they don't know how to find the probability. Or for this case over here, they miss out the fact that it can be orange and purple or purple and orange. They miss out there. So they are doomed also. So for people like us, we are already done with the PDF, right? So next step, we are going to go on to expectation of X, which is easy because we already know the formula, right? So for A, B, and C should not be a problem. Or rather, in fact, everything here should not be a problem. Right? Okay, maybe only C and F will have a bit of a hiccup.
Do we give it in fraction or?
Yes, fraction is fine. So A, B, D, and E should be fine because they are all like what we have went through just now. But you have to understand that standard deviation of X. Okay, what is standard deviation? Standard deviation is basically the square root of the variance of X. Winnie, you know that?
I mean, I don't know.
Where are you at now? I need to understand where you guys at now.
Our next lecture is binomial distribution.
No. I mean, where are you at now at question 2?
Oh, B.
B. Okay. Okay, you hold on to that. You hold on to that. You don't do first. Don't do first. Okay.
Do
Because okay. Because I just want to get the concept right first. The rest of the questions you can do after the lesson itself because I'm pretty sure you know how to do already. Okay. What I want to go through is C and F here. Okay. For part C, they ask for the standard deviation of X. So far, throughout this whole lesson, I never touched on standard deviation. Well, what is standard deviation? Okay. Variance of X is noted by sigma square. Okay. And sigma is equals to the standard deviation. So to find standard deviation, you just have to square root the variance of X. Understand? And we know that variance of x has the formula of in and out, right? Which is expectation of x squared minus bracket expectation of x squared. Okay, so after you find the variance of x, then that's when you go and find your standard deviation of x. For part D and part E, just now you ladies have already let me know that you all know the properties of expectation and variance, so that one I'm not too worried. But for part F, they're asking for variance of x squared. How are you going to find this? How are you going to find the variance of x squared? Anyone? Jamie?
I forgot.
Variance of x squared, part F. A, B, C, D, E should be no problem, but part F. How to find? How to find? Anyone?
No one.
No one.
Not me. Not me. Not me.
Not you. Then, Madam
Let me think.
Time to think. I give you a clue.
You just square the x, alright.
Sorry?
You can't just square the x, right?
What do you mean by square the x?
Like, square the x alone now.
Very good. Correct.
Really?
So instead of, because now, right, variance of x, now all your x values here, all these x values becomes x squared.
Why?
Because now it's finding variance of x squared. If I'm finding variance of smiley face, I'll be getting expectation of smiley face square minus expectation of smiley face square.
So just finding the variant of part B.
So variance of part B. No, we are trying to find variance of x squared, so it will become expectation of x squared to the power of 2 minus expectation of x squared bracket to the power of 2. Because all your x values here is going to get squared. You understand? Vinny, you understand?
Yeah.
So this will get a bit intense because we will get expectation of x to the power of 4 minus expectation of x squared to the power of 2, which you have already found in part B, like you said earlier. So the only thing that you may have to find is this.
That one just X the power of 4.
Correct.
Then
Correct.
okay.
Okay. I'll let you all touch up on it later because I want to try to cover as many questions as we can because I know that you all understood the concept here already. Okay, ma?
可以.
Yeah, I hope I'm not going too fast, right?
No.
Yeah, very good. Slow is the new fast. Oh, it's very convenient that now I know I can select and delete. Nice. Okay. Let's go. So same thing, setter's intention, break down the question. A random variable takes values of 0, 1, 2 only with probabilities A, B, and C respectively. So this one part, just this one part, is telling me to do what? Anybody?
PDF.
Solid. So this one wants me to come up with a PDF. So you have to draw the PDF during exam first. Like maybe a rough sketch by the side is good. Okay, we have 3 values. So we have 0, 1, and 2. We have A, B, and C. Right? Okay. So given that expectation of X is equals to 4/3 and a variance of X equals to 5/9, so why did, so I will ask myself, why did they give me this? You know, I'll ask myself, why? I have 3 variables and then they give me these 2 hints. Sorry again?
You can do simultaneous equation.
Very good. Very good. So when you say that, right, I know you are already getting ahead of the setter. You know that they give you 3 variables means you need 3 equations to solve this question because you're trying to find A, B, and C. So this will, from here you are going to get your first equation. From here you're going to get your second equation. Where can you get the third equation? Renee,
What?
where can you get your third
A
equation?
plus B plus C equals 1.
Okay lah, actually correct lah. You don't need tuition already.
Okay, bye-bye.
Bye. Correct. So this equation, this is your third equation. From here you get your first equation, right? You know how to formulate it, right? Expectation of X. Yeah. Then variance of X, you also know how, right? Okay, why not you formulate the equation first? Because the solving part, right? Do not be stupid and solve it manually. You understand what I'm trying to say?
What?
Do not be stupid and solve the simultaneous equation manually.
I use GC.
Correct.
Okay.
Remember, once you get the 3 equations out, plug into your GC and say using GC, A equals to what, B equals to what, C equals to what. Anyway, Jamie, Well done at identifying that you need to use simultaneous.
I'm done.
Okay. So everything clear?
Yep.
So just by identifying the setter's intention, why did they give me three variables? You know, why did they give me three unknowns? Why did they give me two clues? Keep asking yourself why. Then you will get it. Because sometimes during an exam, 3 hours, you will just don't. Once you ask yourself why, you will get to your answer. Thank you. Oh, okay. Hey, Jimmy, you're still there, right?
Yeah.
Okay, good. Okay. Question 4. For the discrete random variable x, define the probability distribution. They give you. Oh shit. They gave you PDF, right? They ask you to find expectation of x and expectation of mod x. And find? Very easy. Okay, expectation of x, no problem. But what about expectation of mod x?
Just mod the X.
Exactly, you're right. Basically, it's summation of mod x times its probability. Okay?
Okay.
Okay, next up. The random variable y is defined by this. Okay, where x1 and x2 are two independent observations of x. Okay, what do I mean by independent observation of x? Okay, although they are independent, but they still follow this table. The probability will still follow this table. Okay, what do I mean by independent? Let's take into account NTUC. You know NTUC? Okay,
Yeah.
so let's say on the shelf, right, we have like a lot of Coke, you know, Coca-Cola, a lot. So they will tell you that, okay, this Coca-Cola, right, in this Coca-Cola, the probability that, oh, this one cannot use, I cannot use Coca-Cola.
Lesson. You don't need to use the interactive one once you use laptop.
Sure.
Huh? But you on the wire there, what is it for?
I'm charging it.
So can take out.
When it's fully charged. When it's fully charged. I was supposed to do a question.
No. I was waiting for you.
Okay.
Okay.
Sorry.
Yeah. So two independent observations basically means like, imagine that.
Yeah. Okay, that's it for today.
Sorry, wait.
It's okay.
Oh my god, it's not freaking noisy. Wait.
It's okay.
Um,
At any point, right, you think it's too noisy, you can mute yourself.
yeah. Okay.
Yeah. But okay, yeah. Okay, basically,
Yeah.
in short, right, two independent observations means, right, I take two Coca-Cola cans off the whole Coca-Cola shelf. There are a lot of Coca-Cola water bottles. I'm just going to take two. Those are my two independent observations. Maybe I want to measure the amount of sugar in the Coke. Okay. So for for this y, what happens is that I'm going to use the two masses of sugar in the Coke. I'm going to add them up together because it's x1 plus x2. Okay. So now we're going to find the probability distribution of y. So we need to know what are the different variations that y can take on. So what are different values that y can take on? It can be -2 with 0. It can be -2 with 2. It can be what else? 0 with 2, right? It can be -2 with -2. Basically, in short, right, is -2, 0, 2, -2, 0, 2. It will go in all directions. It can be like that, like that, like that. Like that, like that, like that. Like that, like that, like that.
I'm sorry, can you explain again?
Can, no problem.
Cause
No
I
problem,
was
no
doing
problem.
some stuff.
Can, no problem. Okay. Jimmy, listening or not? This one important.
Yeah.
This one very important. Listen, okay. So over here, they are asking us to find the random variable y, and it's defined by x1 plus x2. Okay, I'm mentioning it. This is really a very important setup. Y is equals to x1 plus x2. So each x value, right, can take on -2, 0, and 2. x2 can also take on -2, 0, and 2. We are going to add these two x values up. These two x values are random variables. I do not know whether it will take on -2. I do not know whether it take on 0 or 2. I don't know. Okay, so you have to take into account for every single permutation of it. Okay, so which also means that x1 it can take on -2, 0, or 2, I don't know. x2 can also take on -2, 0, or 2. So in the event where x1 takes on -2 and x2 takes on -2 also, so we will have to use 1/4 times 1/4. Understand what I'm trying to say?
Times.
Yeah. Why? Because we want x1 to be -2
Wow.
and x2 to be -2.
Okay.
You sure you understand? If you don't understand, I can explain again. No problem.
But
Give
why
me a-
times not plus?
Okay. Good that you asked.
Because it's n.
It's n. Because now I want probability of x1 to be equals to -2 and x2 to be equals to -2. Then after that, I have to find probability of
So you add all those up. Oh.
correct. x1 to be equals to -2 and x2 to be equals to 0. Probability of x1 to be equals to -2 and x2 to be equals to 2. Probability of x1 to be equals to 0 and
You really list out all?
yeah, have to.
Like there's no other way.
No other way. This is the only way to find a probability distribution.
A bit much.
Yeah, understand. I mean, you can choose to not list out and straight away show them the distribution, but chances are you will miss out something. Well, actually, the best is to draw table. Vinny, Jamie. The best is to draw a table. I just realized. Okay, this will be a very clear presentation.
So x1 is the horizontal, then x2 is vertical. Okay.
-2, 0, 2. -2, 0, 2. So you can have -2 and -2, which is -4. That is one discrete value. You can have -2 and 0, which is another one. -2 as another discrete value. -2 and 2, which is 0 also. Then we can have 0 and -2, 0 and, okay, 2 and 0, we can have 2 and 4. Yeah, these are all the values that we need.
Wait, so the values in the green box is the...
It's not the probability distribution. This is the probability distribution of y.
Then what's that in the green? What's the...
This is just for us to understand what is the probability when we have x1 being -2 and x2 being -2. Then from there we can add up to go into this one. Because as you can see, when x1 takes on -2, listen, when x1 takes on -2 and when x2 takes on -2, -2 plus -2 will give you -4, right?
Yeah.
Yeah, that's why this -4 becomes one of the discrete value for y over here in this equation. So over here, when we do the PDF, we have to list out all possible values of y. So how I get this -4 is from -2 plus -2. How I get another discrete value -2 here is when I use -2 plus 0, or rather 0 plus -2 also can. How I get 0 here is when I have 0 plus 0. How I get 2 here is 0 plus 2 or 2 plus 0. How I get the 4 here is when I have 2 plus 2. Jamie, you understand?
Mm-hmm.
You understand what I'm saying? Don't so now.
Yeah.
This will come out. Yeah. So why do we have to do this table? Is so that it's easier for us to add it into the boxes later. Really, once you're done, you let me know.
Done.
Done,
But then what I write for the P...
Py equals y, right?
Yeah.
Okay. So Jamie, listen, this one very important. So once you're done with this table, right, this will tell you basically what this table does. What this table does is for us to understand when x1 equals to -2 and when x2 equals -2, what is the probability here? when x1 equals to 0 and when x2 equals minus 2, what is the probability here? So that after it's easier for us to add. Add what? You'll be asking me, add what? Okay, let's take a look at this. How do we get minus 4? It's when x1 is minus 2 and x2 is minus 2, right? Right? It can also be it also can be no, there's only one probability, right? x1 minus 2, or it can be, yeah, there's only one probability here. But over here for this, for minus 2, right? It can be,
There's 2.
okay, it can, for minus 2, it'll be x1 minus 2 and x2 0. Or it can be x1 0 and x2 minus 2. Make sense?
Yep.
Yeah. So over here we need to times 2. To get 0 is only just 0, 0.
But it's 2 and minus 2.
What do you mean? Oh yeah, correct,
Minus
correct.
2.
Oh yeah, you're right, you're right. 2 minus 2 or minus 2, 2. Oh my god, we have 3 now. You're right. I missed that out. So you have to add up all the probabilities here and then put into here. Put into this box. Okay. Then for 2, it will be 0 and 2 or 2, 0. Likewise for 4, it will be 2 and 2 only. Okay, this question is really very tedious, but it's just tedious. It's not. It's just complicated. It's not difficult. There's a difference.
Then what now?
So once you find all this probability inside here, right? Okay, once you find all this probability here, then you're done. You're done.
That's the answer.
That is what they want you to find. Can you see?
Oh my gosh.
Yes. That's why. Understand the setter's intention. Look, it's so colorful here. Always come back to setter's intention. What did they want you to find? Because sometimes we will get lost.
Wait, you mean so P y equals to y is not 1, 2, 3, 2, 1.
Sorry again?
It's not the number of.
No. It's about the score of y. What's the score that y can take? Because it's x1 plus x2. So it has to be x1 can take on minus 2 plus minus 2, which is minus 4. That's the lowest. Or minus 2 plus 0. 0 plus minus 2.
So the answer in the box is not 1, 2, 3, 2, 1.
What do you mean by answer in the box?
Like the part you highlight.
Okay.
Is it not 1, 2, 3, 8, 2, 1?
You mean it's 1, 2, sorry.
Yeah, it's not right.
It's not. It's the probability,
Why?
which means you need to use. That's why I asked you to do up this thing. That's why I asked you to do up this box. So that after it's easier. You have minus 2, which means it will be this probability here. Minus 2, 0. Minus 2, 0 is where? Minus 2, 0 is here.
So I just times that and then I add.
Yeah.
Oh, what the shit.
Yes, it's very tedious. I agree. So a smart move, right, will be that, right, Renee?
What?
I will find for this, I will find for this, I will find for this, and I will find for this. But I will not find for this. You know why?
Cos. Not 1 minus.
Very smart.
Done.
That's all. Jamie,
Yes.
you understand or not?
Yeah.
You sure? Ah?
Yeah, why?
Okay, good. Just want to make sure you're there. Okay, next. Okay, one last one. Okay. Let's break down the question first. Okay, a bag contains 3 red balls. Oh dear. 3 red balls and 1 blue ball. So I have 3 red and 1 blue. Okay. Then a second bag contains 1 red ball. Okay, there's a second bag. 1 red and 1 blue. 1 red, 1 blue. A ball is picked out of each bag. So I have separate bags. This is bag 1. This is bag 2. A ball is picked up from each bag and then placed in the other bag. Wow. So there is a transaction going on. Okay. So it's going to be like that. Like that. Okay, a ball is picked up of each bag. Means I'm going to pick up a bag from bag A and put into bag B, and then I'll take out from I'll take out a ball from bag B and put into bag A. If the
But
variable
what if
X,
you do the other way around? Like what if you take out a bag B first and
good
put
question,
A?
good question. But let's continue reading the question first, yeah? Okay.
Yeah.
So if the variable X denotes the number of red balls in the first bag after the switches of the balls takes place in the first bag. Oh, I think it's done simultaneously. If the variable of X denotes the number of red balls in the first bag, so X is equals to number of red balls in the first bag. After switching. That's what you have to state. Okay, find the probability distribution of X. So we are only going to do it one time. Okay, I'm going to take out 1 ball out from A, 1 ball out from B, and then put it into the adjacent bags. And it will be done simultaneously. It will not be like A put to B, then after that from B, and then I take and then put to A. They did not say that. Right? Yeah, but right now, the B is not our concern because our spotlight now is on A. Right? Agree? So we need to, so they what does the question want? What's the status intention? The probability distribution of X. Same thing. We have to draw a table again. So to draw this table, we need to know what are the values that X can take. I do not know what the values that X can take first. X is the number of red balls in the bag after switching. So firstly, right, when we take out a ball from 3 red, 1 blue, right? Renee and Jamie, what are the possible number of red balls that can be inside the bag 1 after switching?
I don't know. Can you say again?
Yeah, can you say again?
Can. What I just said was, what can be the different possibility of the number of red balls in this bag, in bag A, after switching?
2, 3, or 4.
It can be 2, right? Because it's possible that I take out 1 red, right? I take out 1 red. It can be 3 because I might not have taken out any red. It can be 4. Why? Because one of the red can come into from bag B. One of the red from bag B can come into bag A. Make sense?
Mm.
Any other possibilities?
Maybe have.
Maybe have.
No,
I think don't have already. I take out 1 red from A, put into bag. No, 2 is the least. Like it cannot go lower than 2, it cannot go higher than 4. So it's 2, 3, 4, correct. So from here, we have to find what is the probability of getting 2 red balls. What do you all think? How are we going to get 2 red balls?
1.
What do you mean?
Wait. You know this probability of X equals to X, right? Is that the what the shit?
What the shit?
Is it 2 or do I need to times the number? Is it 1 or is it, I don't know, like the 1 over something?
Okay. To get 2 red balls after switching, right? In bag A, right? In the first bag, right? Okay. To even get 2 red balls, right? Firstly, there are a few scenarios. Okay. The first scenario is that I take out. Okay, actually there's only one scenario. I take out 1 red. I put into B. Okay, as in I take out 1 red from A, and I take out 1 blue from B.
So it's 1 over.
So what's the probability of taking 1 red from A? Is 1
over 4.
Sorry, is 3 over 4.
Oh.
Probability of 1
3 over
blue.
4.
Times what?
That's half.
Correct. Okay, just a bit more. Bear with me. We're ending already.
4 times.
Just a bit more. Okay, so to get x equals to 3, can I move on?
Yeah.
Okay, to get x equals to 3, to have 3 red balls in the first bag after switching, okay, it can be that I take 1 blue from A and 1 blue from B, right?
Mm-hmm.
Is there any other scenarios?
Take one red from A, then one red from B.
Solid, correct. Any other scenarios? No more.
No more.
So these two probabilities, you need to add them up together.
Done.
Okay, then to get 4, how to get 4?
1 minus the rest.
Wow, very smart. Correct. So there you go, you have a probability distribution of X. Then after that, the hands part is find the expected number of red balls in the first bag. Easy. The expected number. You know how to find expected number?
The EX thing.
Exactly.
Okay.
That's what. So the setter's intention was to test you on EX for the second part. So just need to times, add. And there you go.
Okay.
Okay. We have finally come to the end
Okay.
of the lesson. I know Jamie is dying.
Yeah.
Yes. Jamie, you may take your leave now.
Thank you.
Hey, then Renee.
What?
Yeah.
Oh,
No, I'm having tuition.
you sure or not? Was it Jamie?
Yeah.
Huh? What?
No, we have ended already. You can go and do your thing, Jamie.
Okay, bye-bye.
Bye-bye.
Bye. Can I
Anyway,
go now?
can, but I want to ask you, like, you just book a consultation with me, okay? So we can catch up on your earlier topics that you need help with.
Okay, use this right thing.
Yeah, we'll be using Zoom. Yeah, but so is it okay?
Yeah.
Because I've done this with Jimmy before. I haven't used this with you before, but it is still smooth, right?
Yeah.
Okay, good. So you just book a consult with me at any time. Maybe on Friday when you have your e-learning, you can just do a 30 minutes one. Don't need to have be a 2 hours thing.
Okay.
Yeah. Okay. All right.
Okay.
Bye-bye.
Bye. Thanks. Bye.
Bye.